All right, 4.2 rules for derivatives. Remember, the derivative is just the slope of a line. That's all it is. And so there's some certain things we can do when we're evaluating a derivative that make it actually pretty simple. For one, the constant multiple rule. This is kind of nice, is that if there's some coefficient or constant in front of a function, you could kind of, for all intents and purposes, just kind of ignore it, because you take the derivative of the actual function and then you could just multiply that same constant back. So it's pretty simple. I'll show you some examples of that in a second. Also the sum and difference rules. So basically, if you're taking the derivative of like two expressions or two functions at the same time and they're being added and subtracted together, you could just take the derivatives of those independently and then just keep that same plus or minus symbol there and just add them back together. So you could separate out functions and take the derivative of each individually, similar to what we did with limits. And the constant rule, the derivative of a constant is always 0. So if you have some constant, we talked about this last video, and we talked about with a limit notation, right? If you have the derivative, like say, it doesn't matter how big it is, say it's like 1,000, the derivative of that is still 0, because that always looks like a flat line, right? It always looks like a flat line with 0 slope, and that's what we're really evaluating here, is just slope. All right, let's go to the next page. So we can use this constant multiplier rule. What would the derivative of this be? We don't know what f of x is, but we do know that we could just pull the 7 out in front. And so that would mean, I'm going to do this follow every step here, but that would mean that we're really just asking for the derivative of f of x and then multiply that by 7. Well, that's easy. That's just 7 times whatever the derivative of f of x is. And so that would be our answer for this problem, because we don't have enough information to evaluate what the derivative is, but we at least know whatever it is. I'm just going to multiply it by 7 at the end. So here's another example, very similar now. So everything's all the same, except for now we know what the function is. So we can actually just say, okay, well, since the derivative we know is going to be 7 times the derivative of the function, well, what is the derivative of x squared? Well, 7 times x squared derivative, or the derivative of x squared, would be 2x. So that means this is just 14x. And now we've solved it out. Relatively simple, very similar to some of the questions you saw in the power rule. All right, let's go to the next page. Okay, so we got a little bit more going on here. Still not a big deal, just using the power rule, same as last class. I can, or last video I mean, I could just go ahead and use the power rule. 2 times 4 is 8, and 2 minus 1 is just 1, so that's just x. And again, the derivative of a constant is always 0, so this is like 8x plus 0. So I don't even really need it, I'm done. Simple as that. A way of thinking about this, without even having to use any power rules or anything, is just think, hey, this is the equation of a line. Lines have a constant slope. So what is the slope? Well, it's right there. It's 2, right? So this answer is just 2. That's all there is to it. Even if I asked you, hey, what's the derivative when x is 100 or x is 35 or whatever, it's always going to be 2, because this is a line with a slope of 2, and it's going to have that same slope the entirety of that line. So all there is to it there. Okay, now we get into some fun ones. You've seen these using the definition of derivative, and so these are just some ones that you're going to want to remember. I gave you guys on the last page, I gave you just some rules, and so some things that you're going to want to remember, because we're going to hit on this more later, but the derivative of sine is always cosine. Okay, and the derivative then of cosine is always going to be, let's go ahead and write it. Cosine in here, I write prime equals. The derivative of cosine is always negative sine. Okay, well, let's think about this a little bit further then. What's the derivative of negative sine? Well, we already know what the derivative of sine is, so I can actually just keep that negative out in front. So let's say I wanted to do, we'll say the second derivative. This is a way we can talk about the second derivative. What would be the second derivative of this? Well, the derivative of sine is cosine. So I'm just going to write cosine, and I have a negative 1 out in front, so I can just apply the negative 1 here, or make it negative cosine. Okay, what if I want to take the derivative again, right? We're going to see this like loop. What if I want to take the derivative again? This is literally like the third derivative. Well, again, I know that the derivative of cosine is negative sine. We already did this part, so I'm going to put my negative 1 out front, times the derivative of cosine I know is negative sine. So what happens? Well, negative times a negative is positive, so this is actually just sine x. And now we can see that there is a circular pattern here, right? Because when I go to take the derivative of sine, I'm going to end up back at cosine. And so we have this circular pattern. I've drawn a little, maybe just a real simple chart for you of how to think about this. But if you start with sine, the derivative is cosine, then it goes negative sine, then negative cosine, and then it starts back at sine. And this just repeats forever. So it doesn't matter, which one you're on, you should always be able to find the derivative of the next trig function there. So these just have this like circular effect. It's really interesting about sine and cosine. All right, that's it for the rules of derivatives. See you guys on the next video.